So here's Lab 2. So I kind of preface what Lab 2 is. Lab 1 last week kind of focused on the U-tape and the charges, kind of observing the charges and the charge distribution associated with that. We didn't do any calculations as far as charge distribution goes, but we did calculate the relative point charges and to observe or calculate the charge on the tape itself because of this interaction. Lab 2 is kind of an extension of Lab 1 in that we'll use most of the materials that we calculated in Lab 1 in kind of the same experimental aspect as Lab 1, but instead what we're going to be doing is extending that with the new thing, the charge distributions that we've learned about in lecture, and using that to determine the charge on the tape itself using the electric field of a rod calculation. So, kind of reviewing what Lab 1 was. Introduction, we utilized a piece of tape in order to observe the electron transfer between the respective surfaces and to calculate the electrons transfer between the respective surfaces. To the right is kind of the diagram of experimentation. I'm not going to go too far in depth to this just because this was last week's lab and I want to cover Lab 2 more in this 5 minutes that I have here. Involved principles would be Newton's second law, force equals mass times acceleration. In the case of the experiment, we're going to be using acceleration due to gravity, which is 9.8. And then Coulomb's law here, force, electric force, formula shown to the right, 1 over 4 pi e naught times q2b over distance squared, which is the d represented in the formula right there. Results coverage, what exactly happened. So the charge tapes like charge repelled, as both are known to be positive charge. Charge was determined to be 1.52 e to the negative 8, which will be important in inputting to our electric field the rod calculation. But the diagram to the right is from the instructions and kind of shows what the intended result of the experimentation was. Here's the experiment kind of covering basis of Lab 1. Neutral piece of the tape was placed on a solid flat surface. Another tape, which was assumed to have neutral charge, was utilized. The initial tape, which was present at the surface, was quickly peeled up to leave the base tape, assuming that there was near objects. Distance was taken into consideration during the calculation with the formula that was observed. Qualitative results from the experimentation, I learned that the U-tape was not attracted to the tape hanging, likely due to the ideas that the charges repel. However, the U-tape was attracted to objects that would be deemed neutral to test, such as the pen. Here are the calculations. Here I'm running I have enough time. So the mass of the tape was 0.172 grams, length of the tape was 0.172 meters, tape width 0.0200 meters, floating distance was 0.016 meters, force equals mass times acceleration. Doing the calculation right there, we get the force to be 0.00169 newtons, and charge calculation using the Coulomb's law would be 1.52 e to the negative 8. Here's the glow strip code representing each of the respective constants, and then the calculation code is shown here with force of gravity, force of electricity, and the tape charge and the tape B electron count. So continuing on for this section that's important, determining the excess charge on the one piece that was involved in Lab 1, utilizing the glow script to provide a computational model for the excess charge determination. From the experimentation, the findings were that positive charge on the tape from what was calculated, charge on the electric chip as shown prior was 1.52 e to the negative 8, calculated in 1. Electric field for the rod is shown on the next slide. Electric field for the rod calculation, we must use the tape as the rod for the calculation purposes. It will assist in the determination of the net force on the tape itself. So it says the equation shown to the right, but for some reason during this recording it's not shown. So to mitigate having to do it all over again, I'll just read it out. So the formula is 1 over 4 pi e naught times q over r parentheses r squared plus distance divided by 2 squared to the 1/2 power or square root times r hat. And this is the estimation for the charge on the tape, but we can say that this is inaccurate just because the tape is a point charge and not really a distribution of the charge is important to take into account here. So here's the calculation with that formula. So the discussion section is going to be very similar to Lab 1 in that charge is potentially not completely neutral during experimentation, and what if the tape, if one somehow was not affected by my handling, it was rather handled by an insulator. If that is important to take myself out of the equation, unfortunately due to the design of the experiment I was unable to do so. However, if I were to do the experiment again, I would take that into account. That's all I got for Lab 2. Appreciate it.